Welcome back, everybody. This evening we're going to talk about modeling exponential growth and decay, and then work our way to compound interest notes. I'm going to start with modeling exponential functions, and we have two types of equations. They look exactly the same, the exception of, for growth, we have addition, and for decay, we have subtraction. So your initial amount for both is A. Your growth or decay factor, which is going to end up being your base, is found by either the 1 plus R or the 1 minus R. And then the rate is the percent increase or percent decrease, or R, in decimal form. That's the key, in decimal form. So let's review changing from percents to decimals. If I'm changing from percents to decimals, we move decimal 2 places to the left. And if we're moving from decimal to percents, we do the exact opposite. Move decimal 2 places to the right. And you will need to be able to go both ways depending on what the question is asking you. Example 4. We're talking about the value of a car. Cars depreciate or lose value. And so we have this model that they've already written for us. And T is the number of years since the car was purchased. So our first question is if this is exponential growth or decay. Now remember in our last set of notes that A was after the equal sign and B, or your base, was in parentheses. So if I'm looking at that base of 0.85, I'm saying, well, that's between 0 and 1. If it's between 0 and 1, then this is an exponential decay problem. So how much is the car depreciating, or the value decaying, each year? Well, 100% is the car keeping exactly its value all the time. So if we're decaying, decreasing, depreciating, we're subtracting. And that 0.85 decimal changed to a percent is 85%. So 100 minus 85 is 15% decrease each year. 3 years after it was purchased. That means we're making T 3. So 25, 0.85 to the third power. Plop that in our calculators, and we get a value of about 15.353. Now remember, that's 15,000. If I have thousands, that means I'm moving my decimal 3 places to the right to get the number value. So 1, 2, 3 means the car is worth $15,353 in 3 years. Now they want us to estimate, when will a car be about $8,000? Well, that's about half of where our value is now after 3 years. So I think I'm going to start with 6 years. So I'm going to do y equals 25.85 to the 6th power. There's no one right or wrong way to start estimating. You just have to start plopping some numbers in for time and see what happens. So when I put this in our calculator, we get 9.43 or $9,430. That's still too much, but it's close. So let's go to 7 years. 25.85 to the 7th. And when I do that in my calculator, I get 8.01, which is about $8,010. That's exactly pretty much what we want. So about 7 years. Again, we're estimating, so that's as close as we can get. All right, a guitar. Bought it in the year 2000 for $12,000. So there's our A. That's our initial amount. The value is increasing, so this is a growth by 14% a year. 14% is our rate. If I move my decimal twice, that's 0.14. So write the exponential model. We're using the growth model because of the increase, which is this. So I'm plugging in 12,000 for A, 1 plus 0.14 for R to the T power. I'm going to clean this up a little bit by adding the stuff inside the parentheses, and our final model or equation is this. Now it says estimate the number of years it will take for the value to reach $60,000. Well, I have no idea how long that's going to take, but we're only at 12 right now, and so I don't know. Let's try 10 years. So I'm going to replace T with 10, plug it in my calculator, and I get $44,486.66. Not close enough, but getting there. So next, let's try 12 years. So I'm going to plug that in my calculator. And at 12 years, I am at $57,814.86. That's really close. So let's try the 13th year and see what we get there. So I'm going to replace T with 13, plug it in the calculator, and 65,908.94 cents. So it looks like between 12 and 13 years. So if we're talking about the guitar being purchased in the year 2000, that means sometime between the year 2012 and 2013. Right, the world population in the year 2000 was 609 billion. That sounds like that's going to be our initial amount or our A value. It's increasing, so this is an exponential growth function by about 1.18% a year. So I'm going to take that 1.18, move the decimal over twice, and that gives us R in decimal form. So R is 0.0118. So write the exponential model or equation. We're using, again, our growth. I'm going to plug in 6.09 for A, because we've already got here that it's written in billions. 1 plus 0.0118 to the T. And again, clean up that inside. We get 6.09, 1.0118 to the T power. Use your model to estimate the population in 2010. So 2010, and remember this model came from the year 2000, means 10 years, which is going to be our t. So y is equal to 6.09, 1.0118 to the 10th power. Plot that in our calculators, and we have about 6.85. And remember, we write billion after that because we said our equation would give us billions. If you are an even hour class period, example 6C is part of your homework points. Example 7. So income tax return, they can depreciate the value of business equipment because equipment loses value over time as you use it. So we're using exponential decay. Here's a computer valued at $27.65. That's our A value. And the depreciation rate is 30% per year. Ouch, that's a lot. Move that decimal over and you get R is equal to 0.3. We're using the decay model, which only changes from 1 plus R to 1 minus R. You plug in your A of 2,765, 1 minus 0.3 to the T, and then remember, clean this part up so that our final model or equation is 2,765 parentheses 0.7 to the T. If you have an odd hour class period, 7B is your homework. This is where we're going to stop for today. Have a good night.